Okay, today we're going to talk about disjoint dynamic memory allocation. Disjoint dynamic memory allocation using this disjoint dynamic memory allocation is exactly the same as using contiguous dynamic memory allocation. If that was actually true, then we wouldn't be having this discussion. It's not exactly the same. It's almost the same. The calyx, the malix, the free, the testing, all of that remains true. But in order for this to do what we're trying to make it do, disjoint dynamic memory, we're going to need a second array of memory pointers. In order to allow your program to use all available space in the RAM, meaning on the heap, you need to create a table, a new table like a table of contents or an index to a book. So here's an index to a book. Notice the some type of topic and then the page number, topic and page number, topic and page number. When you're dealing with disjoint dynamic memory, basically the same thing. Your program will have a separate array that will be used to store addresses or locations of data. You could think of this separate array as this index to a book. So here's an example of various elements throughout the heap in memory. Here's an element that has maybe this hypothetical address of 001. Here's another element with another address far away from that one, and an element somewhere not in a line with that. Here's an element way over here. In other words, we're no longer dealing in contiguous memory. We're dealing with disjoint memory. I could pop a node here or here or here or here or here until there's absolutely no space left on the heap. This picture represents, to the left here, the disjoint locations. Each element on the heap is going to have an address that's given by the operating system via the calloc or malloc command, and then that address is going to actually store the data, whatever type of data it is. The pointer array will store each of these addresses as they get placed, in the order they get placed on the heap. So here are these elements out here on the heap, and here's this separate pointer array that I keep talking about. Just like any array, it has indexes 0 through 11, or there should be 12 nodes out here, or elements. Notice I keep saying node instead of element. If I say node, I mean element. If I say element, I need node, or mean node. Here's all the addresses of each of these nodes. So for example, 9867 points way down here. This guy points over here. This guy points up here, and so on. So looks like a real mess. But this index table keeps everything straight. Keeps everything straight. To use this pointer or this pointer array or this index array, you need to create it using calloc or malloc. Once you create this guy, you will place the address of the very first element, for example, the element that's at the address 9867 in the first element of this array. Next time you use calloc or malloc, you'll place it here, here, and so on, and so on. Here's my program, and my program would be used to create the array of pointers and to create the elements in the array. So just like any program, you're always going to have your comment header. You're going to have your preprocessor directives, followed by, should you have any structs, you'll place them here, or you could put them in a separate header file. And if and when, and you will be using functions, your function prototypes will go here or in a separate header file. So what I did in this program is I made a small struct called auto, and auto has a make, model, year built, and a cost. In main, down here in main, I created two variables, effective size or E size. I kind of like that better than count. I started to use that a week ago. And the actual size. Now, if this was a real program, size would not be hard-coded. I would ask the user, how many automobiles are we going to have? Once I have that set up, the next thing I'm going to do is I'm going to create the array of pointers. And you might think that that would look something like this. Something like this particular line. Auto pointers array. Be nice if that worked, because that kind of makes sense, but it doesn't. That syntax is not valid. So to create this array of pointers, to actually create the array of pointers, you will create an array. An array, this is how we create an array on contiguous memory of pointers. So it would be data type pointer to pointers array. So the first thing I need to do is I need to create the array of pointers, and I want to create that on the heap, Well, to do this, I will say calc, whatever the size of the array is, size of, notice this is not size of auto, it's size of auto pointer, size of auto pointer. And I return that address into this array called autos. So this autos is actually going to become my array. Now, if I had that array, the next thing I might want to do, and I don't have to do this all at one time, is to take the array and build all the elements. So here I did a loop and I executed a calc command, size times, storing the address inside of this array autos. So each time calc fires off, it could be grabbing memory here or here or here, just anywhere on the heap, and it keeps it organized with this array of pointers. For now, I'm going to stop because that's enough. It's about 7, maybe 8 minutes in. I'm going to review real quick this program. Start like any program, my preprocessor directives, my struct. I'm going to have prototyping functions here, my effective size, my size. I create the array itself. I create the array variable pointer itself, and here's where I actually create the array itself. No array has been created here. It gets created here. And this creates all the elements in the array, and that's all I'm going to do for this program. Back to my slideshow. So as I said when I was in that program, this is the wrong way, and this is the right way. This is the right way. This is, again, I'm back into the slideshow, but this is the same code I showed you in Visual Studios. This is creating the addresses of all of the elements on the array. And here's that same program as a slide. Okay, in summary, just remember everything we know about contiguous dynamic memory is still necessary. We still need calc, malloc, and free. The only difference is we're going to need this new array to serve as an index to the elements located in the various places in RAM or on the heap. You're going to create an array of pointers. Remember, whatever the data type is, star array, left and right, square bracket does not work. That would make sense, pointer to an array of pointers, but it doesn't work. This is the syntax, data type, pointer to pointer array. This is how you create an array variable. The pointer array is placed on the heap. So the array itself is on the heap. Each element of the pointer array is an address to a piece of data on the heap. If you keep this straight, then this concept is easy. If you get lost with this, it's going to be extremely hard, difficult, almost impossible to follow. Okay, it's about 10 minutes. That's enough for today. See you in the next video.